All right, can you all see that? All right, good.
Yep.
All right, awesome. All right, so oh, I have a mouse. There we go. Hello. All right. So yeah, as Julia said, my name's Chase. I'm a machine learning engineer at CoStar Group, where I tend to focus on the commercial real estate domain. If you're interested in connecting after this talk, there are my various links. Feel free to reach out. All right. So what do I want to talk about today? So this talk basically has two parts. In part one, we're going to talk about, so you want to consume a model, right? So how do we bundle a model into something that an application could potentially consume? And then in part two, we're going to look at, okay, what if we have more than one model that we want to put together into a pipeline? What are some of the different options that we have available to us for doing that? All right, so to kick things off, so you want to consume a model, right? So what I've kind of seen in my experience is there's sort of two major ways that models are typically consumed. In the first setup, we have sort of a batch processing based approach. So this is usually where the problem's presented as we want to process all the files in like a directory or process all the rows in a table, right? So some batch of data that we want to process in one large chunk. And this can be really good for generating like recurring reports or doing sort of a one-time data patch, depending on what you're trying to do. The other way that you can do this is sort of in process, or some people kind of call this real time. And this is usually presented as sort of like when the user does X, we want to send the data to the model and then immediately get back some kind of response, right? And so this can be used to generate sort of inference as the result of some user doing an action, or sometimes this is also used to process like a continuous stream of events. So in the first case, there's a lot of really good tools out there for doing batch processing. We've had a couple of talks about this in the past. Two I just wanted to briefly mention are Apache Airflow and Spark. I'm not going to be talking about this for this talk. I just want to let you guys know that this is here, this is a thing. But for my talk, I want to focus on the sort of second case, which is the in-process or sort of real-time use case. All right, so here's a really simple example, right? So we have this company, this fictional company, we're going to call them Pet Photo Co. And they would like to enable a new feature in their web app. So when somebody uploads a photo of either a dog or a cat, we would like to suggest the corresponding cat or dog tag to them so that they can then tag it in the app. This is a purposely very sort of simple sort of machine learning setup because we want to kind of sort of focus on the actual like infrastructure behind the model, not the actual modeling part for this talk. All right, so we have a couple assumptions that I'm going to make with this scenario. So the first one is our input is small, right? So we want to process one photo at a time from a particular user. So a user is not going to be uploading multiple photos at once. In addition, our input is coming in sporadically, right? So we don't know when the users are going to be uploading the photos. We just know that at some point in the future, there will be photos being uploaded, but it's not like any kind of scheduled process. And then finally, we have to return the output quickly. We want to send this output of the model back to the user, so we can really only afford a couple seconds, really, to have the whole data sort of flow end to end. All right, so this is where the data scientist shows up, right? And they say, okay, I've trained some really fancy model here, right? Which achieves great, insert some performance metrics here. Here are the model files, kind of, you know, like, good luck, here you go, right? And so the task that we might be given is then, how do we turn this model, like this model file or whatever it is, into something that our application can actually consume? All right, and there's a couple different challenges that come up with that. The first challenge that I usually find when I'm doing this kind of thing is how do we bundle dependencies with the model? This is my obligatory XKCD comic for the presentation. I try to put one of those every one I do, but I found it particularly applicable for this, right? So we kind of get into this scenario when we were talking about this earlier, right? We have some model version and it needs some other, or some package version and it needs some other package version, and they have to align, and then that has some third dependency, and it just becomes a nightmare, right, to try to manage all these dependencies that you might need for the model. So what's one way that we could potentially do this? And so this is where something called Docker, which again has been mentioned a bit in the past, but this is sort of my one slide intro to Docker if any of you guys aren't familiar. So what Docker is it's sort of a runtime for something called a container. And we can kind of think of a container as a small isolated unit of work. And these containers are secure. They kind of get their own sort of namespace, so we can make sure that they don't break out and, you know, access other memory areas of our machine. They're very lightweight. So the idea is that this would be more lightweight than like a conventional VM sort of setup that you might have seen. And they're designed to be scalable, right? So we can spin up multiple containers, we can tear them down to sort of meet the demands of our pipeline. And then importantly, we can bundle all of our model dependencies inside this container. So once we build this container, it'll have the model and all the dependencies with it, and then we don't have to worry about getting into this like dependency hell where we're trying to figure out all the right versions and all that kind of stuff. So Docker is really, really cool, and we're going to see kind of an example of this a bit later. So that's the first challenge we have. The second challenges or multiple challenges that we run into after this is, okay, so we have all these models floating around in space somewhere. Where can we keep track of all these model artifacts that our data scientists have been pumping out? If we're deciding to use Docker to manage all of our sort of infrastructure for this, we have all these containers now floating around, right? So where do we manage all of these Docker containers? Both the sort of the offline sort of image, which would be sort of like the static offline copy of the container, and then the container when it's actually running, right? So how do we manage those two things? And then how do we actually then plug all this thing into a pipeline that our application can consume? So fortunately, the smart people at AWS have sort of thought of all these things for us, and they've created this service called AWS Sagemaker. And this is sort of their platform for doing end-to-end machine learning on AWS. It provides sort of utilities both for training models, which I'm not really going to talk about, but for our discussion, we're going to focus on, it also provides the utilities for serving and managing these models in production as well. All right, so this is kind of what it looks like. For us, we want to kind of focus on the top half of this diagram. So the way it works is when the data scientist gives us their model artifacts, right, these files, we're then upload these into an S3 bucket, so sort of a file system on AWS, and that'll store the file artifacts for us. Then we're also going to take our serving code, so the code that we need to actually then serve this model, and we're going to Dockerize it. So then we're going to have a Docker container. We're also going to upload that to AWS, and it'll store it for us. And then when we go to actually then consume this model, what AWS does is kind of clever. It'll fetch this. By the way, can you guys see my mouse? Is that visible or? Okay, cool. So yeah, so it'll take the model artifact out of this S3 bucket, and then it'll take our inference code container, and it'll kind of stick them together for us, and then it'll expose that behind a REST API that our application can then consume. And then, of course, because this is on AWS, you get all this nice auto-scaling goodness stuff too, right? Quick side note. So again, I said I wasn't going to really talk about batch processing stuff, but SageMaker does also have a batch processing mode, which can be really useful for sort of very simple batch transformations where you're taking sort of the data from one S3 bucket, transforming it, and then saving it in another S3 bucket. Again, not really that I want to talk about it, but I wanted to let you guys know that it exists. It's a thing. So SageMaker is not just for doing the sort of the endpoint style setup. All right, so then if we get back to the challenges that we're trying to solve, we can store all of our trained models in S3. We can store all of our Docker containers in an AWS service called ECR. We can manage them all running in another AWS service called ECS. And then we can expose these things behind endpoints for our applications to consume. All right, so that's the end of my part 1 slides. I want to show you guys a quick little demo of this, and then we'll jump into part 2. All right, so hopefully the demo works. We'll find out. All right, so over here I have a project that I've set up. And by the way, I'll release all this code after the talk so you guys can be dig through all of it and find my mistakes and all that fun stuff. So I have this project sort of set up. It has sort of 3 main parts. Typically, these would probably be separate Git repos, but just to keep it simple, I kind of shoved it all into one. So in the first part right here, we have a Jupyter notebook for training our cat-dog model. Again, I'm not really going to go into it, but if you're curious, you could look at the code for how I trained this model. And then I have my model artifact. So this is the model that I trained. And I've zipped it up in a tar.gz file. All right, so this is kind of like where the data scientists would bail out, right? So they would maybe have some training script and they have a model artifact and they say, I'm done, right? So now we need to figure out how to take this model artifact and then serve it. So the way that we can do that is, like I said before, using Docker. So I have here my little sort of Docker project. And the core component of a Docker project is this Docker file. So what this Docker file is this is kind of the instructions that Docker is going to use to sort of bundle everything up and then ship it off. And when I'm building Docker containers, I kind of like to think of this around like I have a multi-layered cake, right? So I'm building multiple layers, one on top of each other, and then the final thing is my beautiful cake that I'm then ship off, right? And so on that note, we usually start with some kind of base layer. So what's nice about Docker is we don't have to be master chefs, right? We don't have to build the base cake ourselves. There's a whole bunch of sort of base layers that are out there that we can build our stuff on top of. And we can see here that I'm using the Python 3.7 Slim base image here because I want to run a Python application. Quick side note on base images specifically for Python. If any of you guys have been kind of looking into Docker, you may have seen there's a lot of buzz around using something called Alpine Linux as a base Docker image, with the whole idea being Alpine Linux is sort of like a super stripped down version of Linux that has almost no like pre-installed software, and the idea is then you get a really small Docker container at the end. There's one sort of caveat with Alpine, and that's that it doesn't use libc to compile its C libraries. It uses something called muscle. And as a result, it means that you can't take advantage of any of the pre-compiled Python binaries that are out there, which means at worst, when you build your Docker container, it's going to be way slower because you then have to compile all your dependencies from source. And at worst, it's going to be a mess because you're going to get a whole bunch of compiler errors. So it's a very long road to go down. I've gone down it. I'm trying to save you guys the trouble. Don't use Alpine Linux. And I have some supplemental material. If you guys are curious, you can read up more about that. All right, so I'm going to use the normal standard Python 3.7 Slim as our base image. I have to tell Docker basically who I am, who's going to be the maintainer of this image. And then I'm just setting some environment variables, which is where I'm going to install all of my Python dependencies. All right, so at the beginning of this guy, I'm going to become root, and I'm going to update my container. So I'm going to just make sure I grab all the latest up-to-date packages that I want, and I'm going to install Nginx as a web server dependency that I'm going to use to then serve my model. The next thing I'm going to do is I built a TensorFlow model. So this is just some code that I copied right off of the TensorFlow documentation that installs the dependencies for serving a TensorFlow model. So there's nothing super crazy there. And then I'm going to install it. So I'm going to add it. I'm going to add the TensorFlow repo, and then I'm going to install it. One thing to note here is that in order to install or to add this repo, I needed curl and gnupg in order to add the key. But afterwards, I don't really need those for the rest of my project. So it's kind of good practice once you're sort of done with a dependency, if you don't need it anymore. You don't want that to necessarily persist into the final container because that could present more vectors for like security vulnerabilities, all that stuff. So we can see here that I'm then removing those dependencies because they're no longer needed. Now this is kind of tedious, right? So like installing all your dependencies and then uninstalling your dependencies, there can be some stuff left over. And so there's another sort of concept in Docker, which is called sort of a multi-stage build. So you can kind of think of it as putting multiple layers on this cake. And so what we can do is we can add a layer on this cake, we can build some stuff inside of it, and then only take the certain things that we want out of that layer out and then remove that layer. So the analogy is sort of like, let's say we're like in a shipyard, right? And we're building some awesome ocean liner, right? We wouldn't want to launch that ocean liner with all the scaffolding still attached into the ocean. So this is kind of a way that we can build things and then remove any dependencies that we may have in the compile step, and then only maintain our runtime dependencies. So that's kind of what I'm doing here. So I'm creating a new layer that I'm going to call builder, and I'm going to install some additional building dependencies. In this case, I'm installing GCC and libcdev in case I need to compile any C libraries. I'm then going to copy over my Python requirements files. I like to use something called pipenv for managing my Python dependencies, but you could use plain old pip or conda. Insert your sort of manager of choice here. But I'm going to copy over the files that I need to define what my requirements are. I'm going to get pipenv, and then I'm going to install my dependencies. And then here you can see now I'm going back to my base layer. So I've created this sort of construction layer that's sitting out here. And what I'm going to do is I'm going to copy over all my dependencies from my construction layer. So all the Python libraries that I want from my construction layer into my final container. And that's just what these environment variables are doing that I set up here. All right, I'm going to remove some stuff just because we run at CoStar some container hardening software that tries to look for vulnerable dependencies, and Gevent includes some .pem and .key files for testing purposes, and our scanners don't like that, so I just remove all of that. And then I copy over my source code for the project, so the actual Python code that I want to run. And then I set my working directory to be the directory that my source code lives in. And then I set some final environment variables just to keep Python sort of tidy. And then I have my entry point. So this is the script that actually gets run when this container is executed, which we can see here is called serve.py. All right, so that's pretty much it for building this Docker container. If we look at this actual project itself, so we go back here. So we can see here we have our source file, which contains, or our source directory, which contains all of our source code. And the main files I want to focus on here is serve and predictor. The other stuff, this is just, again, taken from like standard AWS template documentation. You can just sort of copy and paste it. So serve is really simple. All this guy is doing is I'm using a sort of a standard Nginx gunicorn Flask stack for serving my app. And all this is doing is it's spinning up the services that I need to do that. So it's starting up Nginx, it's starting up gunicorn, and it's starting up TensorFlow serving for serving my model. And then it's basically just listening to say, if any of these applications die, I die as well. So it'll kill the entire container. So there's nothing really fancy going on here. And then the heart and soul of this container is our predictor. So what this predictor does is it exposes the two routes that SageMaker requires all of our containers to expose. And like I said, I'm using a framework here called Flask. It's a very simple, lightweight framework for doing REST APIs in Python, and it uses these sort of route annotations to define a function that should be called when a particular route is hit. So we can see here we have two routes that we need to expose. The first one is /ping. And what this is used for is this is used for SageMakers to do any kind of health checks, right? So the idea is that if a particular container starts being unhealthy, SageMaker will kill it and then replace it with a new one. So you kind of get that auto healing stuff. So the way that that works is that as long as ping returns a 200 level status code, you're good. If ping doesn't return a 200 level status code, you're unhealthy and SageMaker will kill you. So in this case, I've just hard coded a 200 level status code right here. You could have a more sophisticated health check if you wanted to. All right, and then the big thing here is our invocations route, which is this guy right here. So this is what gets called when you want to send data to your model. And so here we want to classify cat or dog photos, right? So we're expecting, in this case, JPEGs or PNG images. And that's what I'm doing right here. I'm just checking to see, are you giving me a JPEG or a PNG? If you are, great, I'll keep going. If not, I'll 415 you and say, give me a JPEG or PNG file, right? So if we have a JPEG or PNG, I'm going to get the raw data, which in this case we're assuming is going to be an image. I'm going to use a library in Python called Pillow to just kind of convert it into an image object. I'm then going to send that to my prepare image ResNet 50 function, which we'll see in a second. And then I'll send that prepared image to my model, which is this code right here. I'll get the response from the model. If the response is good, I send it back to the user. If the response is bad, I'll have some kind of error message. So pretty straightforward. So like I said, for my model, I'm using something called ResNet 50 as my model architecture. And really all that means is I just have to pre-process the image in a special way in order to give it to my model so it can understand. And so what I've done is I've written a little sort of pre-processing function right here. Very simple. It's just going to resize the image to a particular size, which is what the model is expecting. If the image isn't encoded in RGB, I'll encode it in RGB, and then I'll call some special ResNet 50 pre-processing function on the image and then basically return that. So nothing super complicated here.
Hey, Chase.
Yes?
Could you zoom in just a tiny bit?
Oh, yeah, sorry. That's probably really small. I should have zoomed in. There you go. Is that better?
Yeah, thanks.
Cool. So like I said, one thing to note here is you might notice there's no references to cats or dogs anywhere in this file, right? And that's on purpose, because what this means is that any model that's built with ResNet 50, I could serve with this container, right? It doesn't matter if it's a cat or dog model or some other model. And so I don't know about you, but I'm a pretty lazy engineer. I like to only kind of solve problems once if I can. So the idea here is by keeping this container generic, we could reuse it for any additional ResNet 50 based models that we may have. And we only have to maintain one container as opposed to multiple different containers for each model. All right, so that's actually pretty much it as far as the code that we need to serve this model. We can actually run this container if we'd like. So if I bring up my terminal here, I do have this little commands cheat sheet file that kind of gives you all the steps you would need to do this. So in this case, I have a little bash script that will then serve this model for us. And that's using this local test directory. So what this local test directory is doing is it's mirroring kind of what Sagemaker would set up for us. And what we have here is we have the model that's unzipped for us. And this is important because, again, we're actually not bundling the model itself with the container. The container and the model are two separate entities. And what happens at runtime is that Sagemaker will then fetch that model out of the S3 bucket, right, and then mount it to this container. And again, that allows us to reuse the same container for multiple different models. And so I'm just mirroring that directory structure here. And then all this guy does is he then just mounts that directory to the container in a directory that it knows where to read. All right, so we can run this. So if I go back to my commands, go into my Docker project. All right, and we can serve this guy. Oh, whoops. Local test. Yep, and so normally you would build the container, but that takes a while. So I've already done that, and I'll just call the one that I've already built. All right. So we can see our container is now running. It's booted up its workers, and it's awaiting a request from our user. So this is all running locally, of course. So I can bring up Postman, which I like to use for testing APIs. And this is the route that we expose, right? So we expose the /invocations route. Our container is running on port 8080, so we can hit that with an image. So if we go here, I have a whole bunch of pictures of cats and dogs to test this model with, so I can select one here. And I can send it off to my model. And if we look at the response, so here we get the raw output of the model. So the first number here is the probability that the image is a cat. The second number is the probability that the image is a dog. I sent it a dog, and we can see that with 99%, 99 or 0.99999, whatever confidence, it says it's a dog. So we know that the model seems to be behaving as expected. Okay, so now we have this sort of Docker container. It's able to serve our model, but this is all running locally, right? And so the whole point of this is we want to upload this to AWS. So that we could leverage this model in the cloud. So there's another script in this this project called build and push. And what this does is if you run this script and give it the name of the container, it will then build the container and push it up to ECR, which is Elastic Container Repository or registry, one of those two. And that's where AWS stores all of your container images. So again, I've already done this, but if you were following along, you could run this script and it'll push it up to AWS. All right, so now if we go to AWS, we have here our management console. So we can go to ECR, which is our Elastic Container Registry. And we can see that our container is sitting here in ECR, which means that we can use it. The thing that we'll need here for Sagemaker is we'll need this image URI. This is the sort of the unique identifier that identifies this particular Docker container image. All right, the other thing that we've done is I've gone to S3 and I've uploaded my model artifact into an S3 bucket. So again, we have this model.tar.gz file. So one thing to know, I think I skipped over when I was doing the local test. So Sagemaker will automatically unzip the file for you. So the idea is that you can store a compressed version of your model in S3 to save space, and then at runtime, Sagemaker unzips it for you. But this is the same sort of model file that we saw before. So what we'll need from this guy is we'll need to go here, and we'll need this path. So we can hit copy path, and that'll give us the path to the model artifact in S3. All right, so if I go back to my console here, So then finally, we can use Sagemaker to expose this model as a REST API. So if we go to Sagemaker, there's pretty much three things that we need to create. We need to create a model. So Sagemaker knows that, hey, this file is a model that we can serve. We need to create an endpoint configuration, which defines how we want to serve this model in production. Kind of think of like the number of servers, how powerful the servers will be. And then finally, we need to create an endpoint, which actually uses that configuration to spin up an endpoint. Okay, so the first step here would be to create a model. You can see I've already created one, but if we were to create a new one, we could go here and say create model. And again, we can give it some name, doesn't really matter. Cat dog model. All right, we have to give it an IAM role. So this is how Sagemaker or AWS in general manages permissions. You can kind of read up in the Sagemaker documentation what the specific permissions you would need to assign to this is. It's pretty straightforward though. So I just created a role that allows me to like call Sagemaker, access S3 buckets, that sort of thing. All right, so now we want to provide model artifacts and inference image location. So we're going to use our own model and our own Docker container to serve this model. And we're only going to use a single model. So Sagemaker provides the ability to actually expose multiple different models behind one endpoint. And you could use this for sort of like an A/B setup, right? But in our case, we're just going to host one model. And so what we need to do is we need to put in that ID that we got from, if I go back here, I go back to ECR. So we need that ID that we got from ECR. Right here. So we would need this guy, so we can copy that. We need it here. And then we would need that S3 bucket path to our model. So we'd go here and we'd say copy path. And go back to Sagemaker and paste that in there. And then we could hit create model, and it would take about 15 minutes, and then you would have a model created. Like I said, I already did that though, so I'm going to skip that step. All right. So then the next thing we have to do once we have a model created is we have to create an endpoint configuration. And this just defines how we want to serve our model. And again, we can go here and say create endpoint configuration. We can give it a name. So I'm going to like cat dog config, right? And we can see here that we can add a model. So then we'll have a list of all the different models that we've created. So in this case, we have our cat dog model. All right, and then we have to go here. It's kind of weird. You have to add the model and then edit the configuration afterwards. But we can see here, we can give it different variants. So again, if you have multiple versions of your model, this is how you would know which version of the model served the prediction for some kind of A/B analysis. And then we can give it an instance type. So all the different AWS instance types for serving stuff. We give it an initial instance count. So again, if we want to have multiple copies of the model for scalability purposes, we could give it more than one to start off with. Sagemaker will auto scale based on demand, but if we don't want it to start with just one, we could change that. And if we had multiple different models, we could give it a weight. So that would be kind of like the percentage. So how many, what percentage of requests we want to be serviced by this particular variant. But again, we're going to keep it simple and just keep everything kind of default. And we would hit create endpoint configuration. And again, that would take about 15 minutes to complete. And we'd have our endpoint configuration. All right, and then the final step is we actually have to create our endpoint. This is how we're going to expose our model. So we go here and say create endpoint. Again, have to give it a name. Cat dog endpoint, right? We want to use an existing configuration that we've already created. So we would select our endpoint configuration here. And then we would hit create endpoint. And again, this would take about 15 minutes to run, and you would eventually get your endpoint created. But I've already done that as well for time-saving purposes. So this is our endpoint right here. And we can see that what this endpoint gives us is this URL right here. So this is how our application would then be able to interact with this model. So we can take that guy. And again, we can go into Postman, and we can put him here. So now we have this whole URL. And again, we're using the /invocations route. The only other thing that's important here is that in order to hit this URL, you will need to be able to authorize the application to AWS. And the way that you do that in Postman, for example, is you go here to authorization, you give it an AWS signature, and then AWS will give you an access key and a secret key. I have these stored in environment variables, so you can't steal them from me. but you would have them here in access key and secret key. You tell it what region your services are living in. So in this case, I deployed stuff to the US East 1, the East Coast region. And then what service you want to access. So in this case, we want to access SageMaker. So I put all of that in. And again, we go back here. We can give us, let's try a different image of a dog. And we can send that off to our model. If we go back to the body, we get back the same syntax that we saw before. So now our model is running end-to-end behind an API in AWS. Okay, so that's the end of part 1. Does anybody have any questions right here, real quick, before I start talking about how to chain these things together? Or we're good to keep going. All right. So we have an API, but the output format isn't very friendly, right? So we're dealing with probabilities instead of actual labels, right? So that might not be nice for our downstream consumers to deal with. In addition, we've just received a new requirement from our customer, Pet Photo Co. So they've received word that there's some bad actors in their app that are uploading non-family friendly images to the app, right? And this is obviously very, very bad, right? We want to prevent that from happening. And so they've added an additional requirement is, can we somehow filter these images ahead of time as part of the upload process? Now, fortunately for us, AWS actually provides a service that does this for us, so we don't have to build it ourselves. And we can see how we might be able to leverage this as part of a pipeline with our model. All right, but now that means that we're going to have 2 different sort of services going on here, right? We're going to have our model service that we just built, our cat-dog model, and then we're going to have our image moderation service that AWS is providing us. And so we need some way to plug these 2 things together as part of our API, right? So that we can process both of the image to both of those services to get the response back to the user. So what are our different options for this? So in the AWS ecosystem, I've seen sort of 3 different ways this can be done. The first one is actually just using SageMaker itself. So SageMaker provides some utilities for chaining models together. The second is we can use another service in AWS called AWS Lambda. And then finally, they provide another service for sort of heavy-duty orchestration, which is AWS Step Functions. So we can briefly kind of see how each one of these different things can be used. All right, so in the SageMaker setup, the way it works is they provide something known as an inference pipeline. And so what this is doing is it's actually chaining the models together behind that endpoint that SageMaker is exposing. And graphically, that kind of looks like this. So the request would come into the invocations route in SageMaker. It would then send that to the first model, and then it would take the output of the first model and send it to the second model, and so forth. There's some limitations with this. So first and foremost, you're only able to have 5 models at most per pipeline. So if you have more than 5 models, you're kind of out of luck. You can't integrate any external AWS services into this either. So for our use case, if we want to use this sort of off-the-shelf AWS content moderation service, there's no other way that we can plug this into the SageMaker inference pipeline because it's external to SageMaker. The pipeline has to be linear, right? So you have to feed in the input to the first model and then the second model and the third model, and you have no opportunity for any kind of branching or conditional logic, right? And then the other sort of limitation of this is, like I said before, the output of the first model is fed without any modification as the input to the second model, and so on. So you don't get the opportunity to do any kind of data transformations, or if you need to like preserve state through this pipeline, you're kind of on your own. You have to kind of make the model return the state on to the next model. So it can be a bit more annoying to deal with. But for very simple pipelines, this can be a very convenient option. All right, so the second option is we can orchestrate ourselves. So there was a link that was posted in the data science Slack channel not too long ago talking about different AWS design patterns. I think this would be the aggregator pattern if I understood that blog correctly. But the idea here is we're going to use a Lambda function as kind of our orchestrator. So now in this setup, the request is going to come into our Lambda function. The Lambda function is then going to call the first model or the first service, get back the response, and then call the second model and second service, so on and so forth, right? So the benefits here is there's no model limit, right? Just time. So Lambdas are limited to at most 15 minutes. Although if you're talking 15 minutes, we're probably not in a like real-time API sense anymore. We can access any AWS service we want. We can incorporate any sort of complex conditional logic we might be interested in into our pipeline in the code that's running in the Lambda. But we do have to handle sort of the error correction ourselves, right? So, or the error handling ourselves, right? So if one of these services happens to fail, if we want to try to like restart the pipeline midway through, it's kind of on us to implement that ourselves. And the other thing to note when you're working with Lambdas is Lambdas have this sort of cold start attribute to them. And the idea behind this is that in order to save you money, if a Lambda isn't being used for more than 15 minutes, AWS will actually turn it off, right? So it won't be running. So they won't be billing you for it, which is usually good. But that means that if you hit a Lambda that hasn't been used in a while, it'll be cold. And AWS will have to spin that up the first time you hit it. The penalty for this usually isn't that bad. It's usually only like a second or two. But if that is important to you, there are other services you could use in AWS as an orchestrator besides Lambda that would get around it, that would be sort of running all the time. And then, of course, you'd have to be paying for it running all the time. I have seen some anti-patterns out there where people try to do some stuff where they like try to keep the Lambda warm by like pinging it every couple minutes or something. But I don't really like that. If you're in that scenario, like you really shouldn't be using Lambdas. You use something else. And so yeah, so that's kind of this approach right here. All right, so then approach number 3 is we can use something called AWS Step Functions. And what those are is AWS kind of has this JSON language that they've defined. And this allows us to define sort of a DAG, this directed acyclic graph with all these different steps. And we define all the transitions between each of those steps in this JSON language, right? And what this gets us is it's extremely robust. So AWS has baked in sort of like error handling, retry logic, all that kind of stuff into this for us. And they have some nice analytics and dashboarding and stuff on top. When we're talking specifically about Sagemaker, unfortunately, there isn't a way to directly call a Sagemaker endpoint in step functions, at least not yet. So the way that you have to do it is something kind of like this, where you have a whole bunch of different Lambda functions, and each Lambda function is kind of responsible for one model, and then you orchestrate all those Lambda functions together in a step function. As you might imagine, this can become pretty costly depending on the number of services and state transitions you're doing, because now you have all these Lambdas floating around. The way the billing works kind of for step functions is in addition to paying for all the resources that are running, AWS also bills you for every sort of transition in your step function. So depending on what you're kind of doing, again, this can get kind of expensive. And if you read the documentation, it's not really meant for like a real-time API either. That's not really best practice to use that in this setup. It's really, really good if you have a longer, more complex pipeline that you're okay with like sort of sending the data and then fetching it later. But you don't necessarily want to have like a service hanging, waiting for a response from a step function, at least based on sort of what I've seen. So what I want to show you all is sort of the second setup, which is the Lambda orchestrator, because this is the one that I like to use a lot, and it's very flexible, and I built a lot of sort of simple pipelines this way. All right, and so in order to do that, I want to talk about a little framework that I don't think many people have heard of, and I think more people should be aware of, and that's called CHALYCE. So this is an official framework from AWS, and it's a framework for writing serverless apps in Python. And it allows us to quickly deploy Python code to Lambdas. It provides 3 main components. So the first one is a command line tool that we can use to kind of debug and run our process locally, and also deploy it to the cloud. They have a decorator-based API, so it's very similar to Flask, where we just sort of annotate functions that we want to be executed as a result of like an API call. It also integrates into other AWS services as well, and we'll kind of see an example of that in a minute. And then a really cool feature that I don't really use because our SecOps people don't like it, but I think it's cool. It has sort of a code analysis feature. So the idea here is that if you build your little CHALYCE app, you're calling out to these various different AWS services. And as you saw before, I had to create an IAM policy in order to have the correct permissions for my process, in order to be able to call all the different things I want to call, right? That's kind of a headache. I'm not really a SecOps guy, so I don't really like dealing with permissions. It just seems like a headache for me. So what this will do is this will actually analyze your code and figure out what are the services that you are trying to call. And then it'll generate a minimum policy with like the minimum permissions necessary in order for your process to work. And then it'll attach it to that process when it uploads it to AWS. So it's a pretty cool, nifty feature. And believe it or not, this is actually all the Python code you need to make a Hello World style application. So we just import CHALYCE, we create our app, we create a route, we give it some route. So in this case, it's just the root sort of route. And we give it a function that we want it to, execute. And then what's really kind of nifty is if you're returning things like dictionaries, the people at CHALYCE know that A lot of times people convert dictionaries to JSON to return them, right? This does it automatically for you. So you can kind of return these sort of primitive Python types, and then sort of magically in the background, it'll convert it to appropriate REST sort of responses. So it's really cool. All right, so I want to show you an example of that as well. And this guy's really, really simple. So we can go to this other part of the project right here. Now we have this Lambda project. So this is our CHALYCE app. And can we see here, there's two major parts to a CHALYCE app. So there's this app.py, which is our Python code that we're going to use to execute whatever logic we want in our Lambda. And then we have this config file right here, this config.json, and let me make that a bit bigger. So what this config.json does is this defines how CHALYCE is actually going to upload our app to AWS. And so what he has here is you have to give your app a name. In this case, I'm not going to use the really cool feature that I talked about where it'll auto-generate an IAM role for me, so I'm going to disable that. And then we have the stages. So in this case, I only have one stage called dev. But what's really kind of neat is that if you have like a dev test prod setup, so multiple different environments in AWS, you can have those different configurations all in this one file. And then you sort of tell CHALYCE when you go to deploy which configuration, which stage you want to use. So that's how you can kind of manage your different configurations. So again, I'm going to tell it the role that I've already created that has the appropriate permissions. I'm going to tell it sort of what I want it to prefix the routes in this app with. In this case, I want to prefix it with API. And then I can also set environment variables here. So this is how I like to control how the service knows what routes to call. I don't like to hard code any of that in the actual code itself. I like to store it all in environment variables, and CHALYCE allows us to do that easily. So in this case, we're storing the name of our endpoint in Sagemaker in this cat dog model endpoint environment variable. All right, and then we have our actual app. And again, this guy is pretty simple. We're going to create our CHALYCE app here. I'm going to use the AWS Python SDK to be able to access Sagemaker and Recognition to do those two different steps in our pipeline. So I'm fetching those here. And again, let me make this a bit bigger. All right, and I'm going to fetch the name of my model endpoint from an environment variable. All right, I'm going to skip the invoke pipeline for a second and skip to the end. All right, so this is the route that we want to expose to our downstream application. So I'm calling this route /predict. It's expecting a post request. And notice before when I was doing the Flask setup, I had to sort of manually do my sort of a content type logic, right? So if it was like not an image, I had to yell at them. CHALYCE actually has that built in. So I can just tell CHALYCE, hey, these are the content types I'm expecting. If the user gives me anything other than these content types, yell at them for me, right? So again, super lazy, don't want to do it myself. CHALYCE does it for me. And then I have my actual function right here. So in this case, it's going to return a dictionary, which then CHALYCE will convert to JSON for us. So what we're going to do is we're going to take in the request, presumably an image from our user. We're going to get the raw bytes of that request, and then we're going to send it to our invoke pipeline function that we see right here, and then return the output of that pipeline as a dictionary that then gets converted to JSON and sent to our user. All right, so what this invoke pipeline function does, this is, I guess, where all the orchestration magic happens, right? So we're going to take in an image right here, and then we're going to do some stuff with it. So in the first step of our pipeline, we're going to send that image off to Recognition to do the content moderation detection. So this is a nice little utility that they provide for us. We just give it the image bytes, and then it'll return back this response. This response will contain a field called moderation labels, which is basically an array of all the different moderation labels that AWS detects. And what I'm doing here is I'm saying if that array is not empty, which means that AWS detected some moderation label, I'm going to return a string, and I'm going to say moderation violation, right? But if it passes, so assuming there are no moderation labels that are detected, we're going to send it off to the next stage. And this is where now I'm going to call my Sagemaker endpoint. So I'm just going to use the SDK for Python for AWS. I'm going to call invoke endpoint. I'm going to give it the endpoint name from that environment variable. I'm pulling the content type from the response that we got before, so it'll either be JPEG or PNG, and then I'm going to give it the bytes. And as we already saw, this returns a JSON schema from our model right here. And what I want to do now is I want to just convert that into something that's a bit more user-friendly for a downstream application to consume. And so here I'm just going to load in that JSON as a dictionary. This is an example of how you can actually use the built-in logging functionality in CHALYCE to print stuff out to the logs if you wanted to. So in this case, I'm printing out what the raw response from the model was. And then this is very simple. So all this is saying is that if the probability that it's a cat is higher than the probability that it's a dog, I'm going to return that it's a cat. Otherwise, I'm going to return it's a dog. So again, very simple, but this could be a more complex sort of logic here, right? Depending on what your application needs. But this is where we can convert sort of the raw response from the model into something that's more user friendly. And again, we could have done this in the container itself, but that means we would lose the generalizability of our container, and we have to build a separate container for each pipeline, and I don't really like doing that. All right, so CHALYCE provides a nice utility for actually debugging this stuff locally, which is really, really handy. So we can go to the Lambda part of this project right here. And the command for this is just CHALYCE local. And what this does is it'll read that that config file. It'll create the environment variables that our app is expecting. So it'll kind of set up this nice little debug environment that we can run locally. The other thing you'll notice here is it says found credentials and shared credentials file. So this is another thing. So if you want to call AWS services locally, you can set up this credentials file. You can follow the AWS documentation for that. But this just holds my secret key and the two keys that AWS is expecting. And so then all the code just sort of knows where that is, and it'll be able to authenticate automatically without me having to do anything. So again, we can see that this guy is running locally. So we can hit it locally. Right here. Now it's running on port 8000 instead of 8080. That's just the default one that CHALYCE likes. So again, pick a different image, send it to our model. Right. And here we see it's a cat. So what this did is this actually went out. It called the moderation service. It got back if there were any labels, and then it called my model, got that back, and then sent that back to me. And we can see the whole thing is running end to end. We have our cat predicted here. So again, we can kind of see that the model is working correctly. And like I said, this is awesome because before I knew about like the local debugging stage, and I'm sure some of you can relate, I had this sort of cycle where I would change some code, I would push it to AWS, it would break, I would scratch my head, I'd look at the error logs, and then I would go back and I would edit some more code, and then I would push it to AWS again, it would break again, and just sort of repeat this cycle until eventually, hopefully, it magically works, right? And that's super frustrating, it's super long. So the ability to actually sort of debug your code locally, even though the services are running on AWS, is awesome. And there's also a really cool feature here as well, where actually CHALYCE is looking for modifications to these files. So if I happen to decide, oh, I need to change something, I can just edit the file directly, and without even restarting the entire environment, CHALYCE will detect that change has been made. It'll reload the file, and then I'm good to go. So it's really, really good for really quick, fast debugging setups. All right, so then the final step for this is we need to deploy this guy to AWS, and this is actually even simpler than the SageMaker setup. All we have to do that is say CHALYCE deploy. And what this goes out is this packages up our code, it uploads it to AWS, it'll create our Lambda function, it'll set up the API in AWS for us, and then it'll spit that back out. So we see right here, we have our REST API URL. All good to go. So we can go back here, or actually, let's go back to AWS. So if we go back to AWS and we go to Lambda, we see that our Lambda has been created for us, and it's running Python 3.7, which is what we would expect. All right, so we can go back to Postman. Again, now we can hit that route. Again, I will also have to have the authorization set up so that my local machine can authenticate to AWS. But we can now go here and give it another file. Let's do another one. Dog. Send it off. Cool. And we get back the response here that it's a dog. Now we see here that this takes about 3 seconds, and that's probably because our Lambda was cold. If I send that again, yeah, we can see it came back much quicker, right? So that's the cold start that we saw. So if you're okay with that, Lambdas are good. If you're not okay with that, like I said, there's other options. But now this is our whole sort of two-step pipeline doing the content moderation and the cat dog classification end to end. So I'll leave the content moderation as an example that you all can sort of try on your own. But it does work. We have tested it. It does work. If you send something else to this that might not be that great, it'll flag it for you, and it'll get caught. All right. So we're almost to the end. All right. So I just had some final sort of closing thoughts around this. So what I kind of mentioned in this previous slide, CHALYCE is not just for REST APIs. And where this becomes really, really powerful is when instead of triggering stuff on REST APIs, you use some of the other services that AWS provides. So one of the things it can trigger off of is something called SQS, which is the Amazon Simple Queuing Service. It's just a queue setup, or SNS, which is the topic service. So we've had some talks in the past about sort of like event bus, topic, event-driven sort of architectures. And this is where you can kind of tie this type of pipeline into that very easily. So again, instead of having like this at app route annotation, we just say, okay, instead of triggering this function from a REST API, let's trigger it whenever we get a message from a queue. And then we can read that queue or that message off the queue and then do stuff with it. And when we've used this extensively is a flow kind of like this. So this is a slightly different sort of setup. So the idea here is we're not necessarily interested in a purely synchronous call, right? So we're not having the client wait for a response, but we do want to sort of process files as they come in. So what we've done is we have the client uploading the image to an S3 bucket, and then we have a trigger on that S3 bucket to then trigger whenever a file gets uploaded, and it'll push the location of that file onto a queue. And then we have another Lambda reading off of that queue, those locations of the images, and then it'll send those images to our various AWS, machine learning services and whatnot. And then when it's done, it'll push the responses onto a queue for some downstream service to consume. And where this is really nice, and why you say, well, why have a queue? Why not just have things trigger directly when the files are uploaded to the bucket, is what happens if somebody decides, I'm going to go crazy and upload 10,000 images at the same time, right? We don't want to make 10,000 simultaneous requests to our API. It'll probably explode. And so the queue provides us a mechanism for sort of throttling those requests. So we can send the requests to the service at a rate that it can handle. There's also some nice retry logic baked into queues as well. So like if your service for some reason fails, it can get placed back on the queue a certain number of times. And then you can have like a dead letter queue to handle things that just for some reason can't process. So you can do a lot more sort of fancy analytics that way. But again, it's just very simple. It's just a different set of annotations in your Lambda. And if you're really clever, you can actually serve the same model in multiple different setups. So you can have the same model, same Lambda, more or less, one with a queuing setup and one with a real-time setup, depending on what your different client applications require. And that can also be very, very powerful. All right, I have some further reading references in case you guys are really interested in this. Some stuff around like Docker, Python, more examples from AWS. I also have that article. Actually, somebody beat me to the punch. I have that same article around AWS design patterns in here and some docs around CHALYCE. But that's pretty much my entire talk. Hopefully that was informative. Do you guys have any questions for me?
So I think there's one in the chat from John Naylor.
Oh, sorry. I was like not paying attention to the chat at all, so I completely blew by that. All right, so the question is, if you're also using Sagemaker to train your models, will AWS automate all of this for you so you don't have to go into the console? Sort of yes and no. Yes, Sagemaker can automate sort of creating endpoints without the console. They actually provide like a Jupyter notebook setup for doing that, which I don't really like. What we use in practice to do this is something known as like Terraform or Chef would be another one I think that's out there. But we use like it's Terraform. We write scripts that basically define how all of our architecture is set up. And in fact, CHALYCE, if you guys do happen to use Terraform, CHALYCE will actually integrate with Terraform. So instead of using the sort of the native CHALYCE deploy, you can actually ask CHALYCE to generate the Terraform scripts, and then you can import that into like whatever sort of deployment mechanism you have set up at your company. So it's very flexible in that regard as well. All right. Any other questions?
Hello, Chess. Hey, I have one question.
Okay.
And this may be a little bit more generic. So when you were sharing that info about the step function in Amazon,
Yeah.
kind of feels to me in Azure, there is a similar service called Logic App, which is used to orchestrate functions, Azure functions, instead of Lambda functions in AWS. So is that right? Or maybe you haven't used Azure, but anyone else on the call, is it similar in your experience or different?
Yeah, I'm not an Azure guy, but I know there are some Azure people here, so feel free to chime in if you can answer that.
Yeah, they're the same. They're the same type of product.
Okay. Okay. Yeah, because when you are saying that there is a built-in recovery and restartability, Logic App is not there yet fully, but I just wanted to understand how step functions provide those functionalities.
Yeah, step functions are super powerful. And like I said, for anything that's more complex, that's like more than like 2 or 3 calls that you're not expecting to do in this sort of synchronous real-time route, that's a really powerful way. And I assume that the offering in Azure would be similar. So, yeah.
Okay.
So I had a question, Chase. You mentioned that if the cooldown was not applicable for your use case, that there were other options. Like what would be those other options?
Sure. So if we go back to AWS, I can show you. So one of the other options that I really, really like is something called Fargate, which is part of the Elastic Container Service. So what this is, you can kind of think of Fargate. I don't have any clusters running here, but you can kind of think of Fargate as sort of like a managed Kubernetes setup, if any of you are familiar with Kubernetes. So the idea here is that instead of like setting up an entire Kubernetes cluster yourself, you just tell AWS, hey, here's my container. I want you to maintain X copies of it, make sure it doesn't go down. And this is the amount of CPU and memory resources I want each container to have. And then it spins all of that up for you. And so that's really, really, really nice. So whenever you have services that need to be constantly running that you can't afford to have them running in a Lambda, I'm a big fan of Dockerizing those services still, because Docker is great, and then deploying that on a managed service like Fargate. If you're really, really invested in Kubernetes, you can also, they have EKS, which is a way that you can actually run sort of like vanilla Kubernetes clusters in AWS as well. So those would be the 2 other options that I would recommend for services in AWS other than Lambdas.
Cool, thanks.
Any other questions? I know this was a lot of material, so hopefully some of it stuck. And like I said, I'll release all the code and the slides and stuff after this, so you guys can feel free to play around and all that.
This is really good, Chase.
So.
Yeah, thanks so much.
Okay, here's another one. Any general pointers for consuming a Flask data endpoint from a node request, orchestrating them together via Docker? I'm not sure if I fully understand the question. Oh, okay, yeah. So, like I said, when you're talking about orchestrating multiple different containers together, like I said, there's different patterns for that. One way to do it is, as we saw before, using like the Lambda to orchestrate the different calls to each Docker container. You could also have another sort of Docker container that's like your orchestrator container that's orchestrating all these different things together as well. Or like I said, with step functions, you can have Lambdas trigger to call your services and then orchestrate all of those calls using step functions. Those would probably be the different ways I would explore doing that. So. All right. Well, if there's no further questions, thank you. Like I said, hopefully this was informative, and I'll release all the stuff after the fact so you can play with it.
Thank you, very good.
Thanks. Thanks, Chase.
Thanks, Chase. You're a great presenter, by the way.
Thank you.
Told you that.
Thanks.
Hey, Sam or Julia, you guys want to talk about the upcoming events?
Oh, yeah. You have some announcements. Yep.
Sam, go ahead. I'm on my phone. It's right about to die. So
Cool. I'm sharing my screen. so you guys can kind of see the. You see that?
Yep.
All right, cool. Does anybody have any, like, are they looking for jobs? Anyone want to announce a job that they have that they want to let other members know about? Well, EPON is still looking for data guys, to grow our data practice. I don't think anyone from EPON is here, so I'll do the pitch. But, we're basically looking for someone with like 15 years of Python experience, 10 years of AWS experience, at least 1, but 5 PhDs preferred. I'm kidding. Honestly, yeah, if you feel like you're entry to mid-level, go ahead and shoot me a message, and we'll start chatting about working with EPON. But anything else?
Yeah, actually, CarMax is looking for a data science manager. It's not technically running a team. It's being a senior data scientist, and it's in our realm under marketing analytics. So if anyone knows of any kind of on the data science side, but if anyone knows anyone who's kind of a mid-level data scientist who wants to make change to a really cool company, the great culture, let me know, and I'm happy to make the connections.
Cool. Well, I guess that's it. Thank you guys for coming. Switch back.
Thanks, everyone.
Thanks, everybody.
Appreciate it.
Thanks for coming.
Thanks, Chase, again.
Thanks a lot.
See ya.
You guys.